Okay, new lesson is going to be called Translations Part B. Basically, it's a big review of yesterday, but we add in one extra little feature. The one extra little feature we're adding in is, do you remember where that one kind of function where the one function would swallow the other function? That ends up making a function that got moved. So we're basically going to do a review of yesterday with just a little bit of add-on. All right. So here's the review of yesterday part. Before I started the video, I told the kids to get themselves a graph copied from one of the other parts and put it on a blank piece of paper. So it's kind of look like that. All right. So imagine a test question. It's only fair for us to tell you, like, here's the type of thing you'd have to do to prove you understand this. A typical question would look like this. Y equals absolute value of x minus 3 plus 1. It'd be a pretty easy one. And then they'd say, they could ask you these kinds of things. Which way, or no, what was the parent function? And would you say parabola on this one? No. Do you know what the parent looked like? That would be a fair question for you at this point. Because we did that whole review game and stuff about which function is which. Do you remember what absolute value looks like? All right, so why don't you, number one, sketch parent. As in not moved. The parent is the original one, hasn't been changed at all. And I hope you remembered that that was a V-shape. Raise your hand if you knew we were talking about a V-shape. Good. That's the first thing they could ask you. Second thing they could ask you is, it's been moved. Where should you move it? And then would you please answer that as your second question about this? I'm going to move it up 8 and 4 to the left. That kind of thing. Hopefully you've learned to not trust stuff on the inside. If people get this wrong, it's usually the inside they get wrong. So be careful with that. I'm going to pause for a second on video. So minus 3 it's over here. So doesn't it feel a little bit like that should move over to the left? But it doesn't. You can't trust the stuff on the inside. So minus 3 means you would go to the right 3. All right. Next, how about that plus 1? That feels like up 1. And do I trust it or not?
Yes.
Yes, you can trust the stuff on the outside. So then it goes up 1. Oops, sorry. There. Now the V shape has moved over to the right 3 and up 1. And now why wouldn't I mark it right on the test? Because that's a sketch. There are no distinct points. Okay, there's one, I guess. I could argue that this is perfectly centered right there. That implies that point is on my answer. But do you get, you have to have a few points to actually qualify as graphing versus sketching. Maybe you never have heard the difference between that. But a sketch can be like, this is kind of what a square root looks like. But that's not actually a points. You know what I mean? I'm just kind of sketching it. If you want to get credit for an actual graph, you need points. And I recommend an XY chart. So to finish my question number 2, I would say right 3 and up 1. And so that's kind of what the graph looks like. But I think you'll find that I'm actually off a fair amount. If you really look at where those points should be, let me show you. Question number 3 could be, tell me 5 distinct points that are on this graph. All right, fair warning, I'm not going to say a name, but there's somebody who was using a cell phone that needs to go away immediately or I will take it away. And I'm only being nice here in September. Once it hits October, I see it, it's gone. It'll be sitting on my desk. We'll be having a conversation about it. I like my cell phone just as much as everybody else. I'd like to be checking my stuff. Even while I'm teaching, I'd like to be flip it out, quick check my who just texted me or whatever. I'm not going to do that. Same thing, you shouldn't do that either. You can look at an appropriate time later when we're done. Okay. Over in the corner pocket, can you tell me one spot that you think is on this graph? What comma what? One thing that would be on your XY chart. I'm guessing the answer is no. Judging by taking this long. Okay, so let me help you do this. It's not that hard. You can pick any number you want, any number in the world, so don't make it weird. Just pick something simple, and we're going to put it here on the XY chart. Would you please pick a number for me? 1. All right, I'm going to pick a 1. And where am I going to put that? Into the function, right there. You just said x is 1, so I stick a 1 in, and I see what happens. What is 1 minus 3? Well, negative 2. And then you absolute value it, and it makes it 2. And then you add the 1. The final answer is 3. 1, 3 is a point that's on this graph. Now, in case you hadn't noticed, that is a top 20 thing. Why is it the top 20? Why do I care that you can use an XY chart? Because it can allow you to graph anything. I could give you the weirdest function. You could have no idea like what this function looks like. And yet with an XY chart, you could figure out what it should look like. Like here, I'll give you one. I have no clue what this, when you square it and then add 3, I have no clue what that looks like. Okay, I can't like take the parent function because I mixed two functions together. You know, I got the squared going on and I got the 1 over x. I have no idea what that graph looks like, but I could graph it. Know how? XY chart. Just for a second, look at this one now. Now, some numbers are going to be easier to work with than others. Okay, like you don't want to put in 8 because then I got to go 1/8 squared. It's going to be a little bit of a pain. So I'm going to pick something nice to put in for x. What do you think I'm going to put in for x? Yes, 1. 1 will work nice. So I stick in a 1 and I find out what point that'll make. You know, 1 comma something. Everybody, take a second. Stick in 1 in your head. Figure out what the answer is for this problem. 1 squared is 1, because that's a 1. 1 squared is 1. 1 plus 3? 4. It'd be easy to do something in your head wrong and go like, oh, 1 squared is 2. 1 squared is 1. And then you add 3 makes 4. Do you get that 1 comma 4 is a point on this graph? I have no idea what it looks like, but 1 comma 4 is on it. Over 1 up 4. And then I just have to keep making a bunch more points. And if my points end up doing this, be like, oh, I guess that's what the graph looks like. You know what I mean? I don't know what it looks like till I get a bunch of points and I connect them. Now, I know that you usually know kind of what it looks like. Like, do you know what that kind of looks like? Yeah. And then if I do this to it, do you know what that's going to kind of look like? A V shape that's been moved where? Down 8. But do you know the exact points on it off the top of your head? No. So what you do is you go, okay, well, I know it kind of is down here, but now I got to find exact points. How do I do that? XY chart, stick in any number you want. What's an easy number to put in? 1, absolute value 1 is 1. 1 minus 8, negative 7. 1, negative 7 must be on my graph. Over 1, down 7, that must be 1, negative 7 right there. See what I'm saying? You can get a quick sketch in your head really easy, unless you don't know what it is. And if you don't, even if you don't know what it is, like this one, I could find it by just finding a bunch of points, and I keep on graphing those points until the pattern emerges, and I'm like, oh, connect the dots. All right. So last night, I think the part you could do was you could tell me that this was right 3 and up 1, and I think you knew what the parent looked like, and I think you could even slide it over, but I think you weren't sure exactly where those dots were, and look how I was off. I was actually supposed to hit there, and there, and there, and there, and there. I was a little bit off on my little blue sketch there. And on the test, I would have marked that wrong because I didn't have 5 correct points on my graph. I should have had, I guess this is overkill, 4, 5, 6, that's 8 correct points. You don't have to have that many. You have to have 5 correct points on your graph. All right. So I'd like to check and see if you can really do that. So everybody, would you please write this one down, and you're going to be checking the following equation to get me 5 points on an XY chart. Hint, if you don't know what to do, stick in numbers for X. Any number you want, but choose wisely because you're going to have to square it. So choose strategically. There's just dumb. I'm going to pick, I don't know, 12. Okay, and then there's strategic. Okay, let me see. If I put in something like 12, will that give me a manageable number? Yeah, okay, that could work. Or maybe if I stick in 0, that'd be cool, because then this whole thing, or 8, that whole make the whole thing 0. So choose wisely. Don't just randomly pick something. I think 8 should be one of the numbers you would put in, for example. It works really nice. All right, find me 5 points on this graph. I'll pause where you do that. So here we go. You should have put in, well, you didn't have to pick 8, but 8 works really nice. Do you get why? If you just look at the first step, it goes down to 0, and then 0 squared is 0, and then you add 1 is 1. 8 comma 1 is on your graph. Raise your hand if you had that one right. Good. A lot of people put in 1, I know. Now, the downside to 1, it doesn't always work nice, because this one ends up being negative 7 squared is 49. 49 plus 1 is 50. It's not wrong, but do you get it's going to be hard to find a graph that will have 50 dots on it, 50 spots. So it's unlikely that would have fit on your graph. You sometimes get points that are just too big. All right, so since 8 worked so well, maybe we should put in like 7. 7 minus 8, negative 1 squared, 1. 1 plus 1, 2. If you put in 7, you should have got 2. Did anybody have 7 comma 2 on their graph? Good. And then maybe put in 9. 9 minus 1 is, or 9 minus 8 is 1. 1 squared is 1 plus 1 is 2. Can 2 things come out with a 2? Yeah. Put in 7, put in 9. It's a parabola. It does that all the time. It's like you go over this much, and then you go over this much, and it's because it made the corner right there. It's like a parabola. And it happens that you have the same value for y on parabolas. All right. After you got 5 points, which, do I have 5 yet? No, I only have 4. I better do one more. I might have picked, let's pick I go with a negative number. It's not going to really help because it'll be really big. Now it'll be negative 10 squared, which is 100 plus 1, 101. Negative 2 does go with 101, but it wouldn't fit on my graph. So I'll pick one more and squeeze it in here. Let's say I picked 6. 6 minus 8, negative 2. Negative 2 squared is 4 plus 1 is 5. 6 comma 5. Raise your hand if you had 6 comma 5 on your chart. All right. Do you get the idea? XY chart gives you your exact points. You can do the other part really quick. Watch how fast I can sketch this answer. All right, it's parabola. Move to the right 8 and up 1. Boom, there's my sketch. I'm done. Get what I'm saying? You can't do that on the test, because why? Because it doesn't have exact points. It's true. On paper you can't grab your parabola and move it. But it isn't that hard to go, okay, here it is on paper, right? And then I say to myself, I move all the points over 8 and up 1. I put it like a dot here. And then I go, there we go. See, it still doesn't take long, even if it was on paper. But it won't get credit on the test because it doesn't have distinct points. That's what you need this for, is the XY chart. That's one of the top 20 skills. Get that one down, you can graph anything, even stuff you don't know what it looks like. Just find a bunch of points, connect the dots. All right. So let's get into the smartboard for today. Hopefully you already had found it. And let's get to this page right here. It says function notation and translations. This is going to blend last chapter with this chapter, which makes some sense to try to tie them together. Hopefully you haven't forgotten when one function eats another function. I used the example of the guy getting eaten by the snake. Remember that one? All right. His arms saved him, that's right. So here's g of x, and it got eaten by what? F of x. Now, I want you to do that one. Here's f of x, here's g of x. Let's see if you remember how to do that. Hint, you want to make a big stomach, open area, and in parentheses, for the f function, because it's going to eat g, and you need room. The snakes handle that by having a mouth that can unhinge. Like, your mouth is only big enough to open so far, right? They can undo that jaw muscle and just, like, open their mouth ridiculously big. The snakes can. So here's f. Do I need parentheses inside of an absolute value? Not really, because aren't they kind of the same thing? I mean, they're grouping symbols either way. So I could, though, and it wouldn't hurt. So now I'm going to drop in the g function because he got eaten. There he is. He goes down here. And something you never noticed before, I bet, is that now we have a function that's been moved 2 to the what? Left 2 and what? Down 5. Do you get how that's kind of last chapter, but it kind of comes out with an answer that you can use for this chapter? Okay. So you hopefully haven't forgotten what we just did one chapter ago where a function eats another function. All right. This one, just looking at it from the beginning, I can tell it's already been moved 1 to the right. And this plus 2 here, it's kind of annoying when they're at the front. You can always move them to the back if you want. Plus 2 there or plus 2 there is the same. And that means what? Up 2. So it's 1 to the left and up 2. But wait, that's what it is right now. What if I actually use these functions here? Which one am I using, F or G, in this problem? F. So I'm just going to cross this out so you don't get distracted by it. It's that function there. And you need to feed that function x minus 1 and then add 2 to it. Go ahead and do that one. That's different. It's not a function eating a function. It's you sticking weird things into a function. Try it. Here's a start in case you're kind of like lost on what to do. Stick x minus 1 into that function. There we go. X minus 1 and then minus 5. Raise your hand if you got that far. Okay, good. Now, what else is there? There's also something I left off. There's a plus 2 right here. Where do I put that? Does it look like I was in the inside of the function, or is it on the outside of the function? Outside. So I put the plus 2 here, and then I can put it all together and say it's absolute value x minus 1, and then that net effect is a negative 3. So this function has been moved 1 to the right and down 3. Yes?
Why is it not just the absolute value of x and minus 1? Like, why is the minus 1 in the absolute value?
Okay. It's because, look back at the original problem, they told you to stick that into the f function. Into the f function. Here's the f function. Where can I stick things in? Where the variable is. So I stick that in there. Can you get that the x minus 1 will be inside the parentheses then? Or the absolute values? That's why. Yes? All right. Well, first of all, let's do one thing at a time. This part right here, do you agree that the part I circled, f of x minus 1, when I put it here, gives me, I'm going to replace the red thing with another red thing. It gives me that. Now I just need to add that 2 plus, I'm just bringing it down, 2 plus all that. Now you could put the 2 in the front or the 2 afterward. Either way, that 2 is on the outside with the negative 5. I'm glad you asked, though. So that simplifies down to x minus 1, and the negative 5 and the plus 2 is minus 3. All right. So let's move on. Go to this one that's blue. I think you need a little more practice on g function eating f function or vice versa. So try this. Have the g function eat the f function. I want to pause while you try that one. Then after you're done and you'll look at your answer, tell me, what does that mean? It got moved this way and that way. So hopefully you have stuck the f of x into the g function. So here this guy needs to go into that one. And where can he go? In where the x was. Empty stomach, minus 3. He eats the f function, square root of x plus 1, and there it is. And once I was saying before, I don't really need the parenthesis and the square root. They're kind of the same thing. They group the numbers underneath there together. You could drop the parenthesis, but you don't have to. I'm fine with you leaving it. And what does it mean? Describe the transformations. It goes 1 to the left. Be careful in there. It feels like it should be right, but it's left, and that one is down 3. Raise your hand if you had those parts right. Okay, good. Now, if you had to have an actual graph, not just a sketch, because the sketch is super easy. Watch how fast I can do the sketch. Square root looks like that, and I go 1 to the left and down 3. Boom, I'm done. That won't count on a test. Why? It needs 5 distinct points. That's where the XY chart thing comes in. Yes?
So if it's positive, why am I talking to the left?
All right. I get it feels like it should be to the right, but it is to the left, and I'll prove it by showing you this. Would you agree if I graph this correctly and it ends up coming out to the left, that I must be doing it right? Even though it feels like it should be to the right, I'm going to just prove it by actually graphing it. So how do I do it? I'm going to test x is -1 and see what happens. See if this thing actually goes where I think it is, which is right here. So I'm going to stick in -1. Where do I stick in the -1? In here. What do I end up getting? Square root of 0, which is 0, minus 3, which is -3. I just made a point on the XY table, and it is at -1, -3. And isn't that spot right there? So you can see it actually does shift to the left. Now, your question was more like, why does it shift to the left? I can explain that too. If I just show you this, keep it really simple, and it seems like it should be going to the right. The y is solved right now. If I wanted to solve for x, do you get, first technically I'd have to square both sides, and then I would end up subtracting 1 to get the x solved. If I got x alone, I'd do it by subtracting 1. That's why it moves to the left, because subtracting 1 would move it to the left. Okay? It's the opposite of whatever's in here. That's what you do. So if it was this, do you get to get this solved for x? I'd have to subtract 8. So again, to solve it for x and find out what the impact is on the x, I'd have to do that. And now I have my -8. It actually goes left 8. Okay? So the easy way to say it to everybody is just do the opposite of what you'd think. Feels like it goes to the right 8, must be actually left. The reason why is because when you would solve it, you would do the opposite of this. You'd do -8 on both sides. That's why it's moving to the left 8. All right. Next, let's get to this slide right here. All right. Just generally, do you get, I'm starting with x squared, which is a parabola. Did I just graph that or sketch that? I sketched it. And that's fine for kind of a rough idea. And then if I'm going to take this and do this to it, do you get it's going to move my parabola where? Left. There, that's a sketch. Do I get credit on the test? Nope. Got to have how many points? 5 points. How do I get the points? Well, I make an XY chart, but I better stick f of x plus 1. That's stick x plus 1 in where the x was. That has to go in there, and I'll have x plus 1 squared. And then I make my XY chart, get a bunch of points that I can put on my graph. Just to see, would you please right now Find me 5 points that would be on this graph. And I know my green line's off a little bit. Hint, choose numbers carefully. Don't just stick in 10. You'll end up having to square 10 plus 1, and that's a big number. Go ahead. In this case, sticking numbers into here. Tell me a number you stuck in and why. I'm going to go with, I don't want to say your name on the video. Go ahead. All right. Thank you, M. And what do you get when you put in a 1? 1 plus 1 is 2. 2 squared is 4. 1 comma 4. Raise your hand if you had 1 comma 4 on your list. Okay, good. Do you need 5 points like that? All right. Now, it's really important that you not just list them, that you actually graph them. Because what if by accident you think 8 comma 1 works? You'll be like, whoa, that's way off my graph. You know what I mean? You'll know you probably did something wrong. But 1 comma 4 worked fine. Over 1, up 4. At first you might feel like it's off, but it's because my green line was so far off. I was just sketching there. What if you put in 0? What did you get when you stuck in 0? What'd you get? 1. Because 1 squared is 1. 0, 1 would be right there. And my green line was kind of close on that one, but it was off. Now if I stick in -1, I get 0 squared, which is 0. -1, 0. That was the only point I was like perfect on. So see how I'm making my graph a lot better by finding the exact points? That sketch was not really close. And now I go to -2. You can pick any points you want. That's what I'm picking. If I put in -2 plus 1, I get -1 squared, which is 1. -2 comma 1's right there. All right, I got 4 points. I just need 1 more. I personally am going to put in -3. You could have put in like 2, whatever you want. -3 plus 1 is -2 squared is 4. -3 comma 1, 2, 3, 4. There, the blue dots are way better than the green at being accurate. There, now I've got 5 distinct points on my graph. Distinct means like separate, unique, different than each other. 5 points. Now, I will admit that there are a few graphs where you can't get 5 good ones because it goes off the graph. In that case, if you have like 4 or even 3, like let's say I move a square root like way over here, do you get I might only have 3 good points before it goes off the graph? I'm fine with it if that's the reason. Okay, so we're going to try for 5, but if there aren't 5 that are even on the graph, it's fine if you just do as many as you can. Okay, now your homework for tonight, once again, is the evens. The evens. Now the only thing that we really added was functions eating other functions. Okay, question? What part don't you get? Right, it's not the same worksheet, different worksheet. It's a different worksheet, and you're again just doing the evens. Why am I cutting it down so much? Well, you know if you need extra practice. And if I say to do the evens, but you know you should actually have a few more problems because you're kind of bad at this and you want to practice, that gives you extra problems you could do. It's optional. And I do find, here's my theory on homework size. Doing some homework helps a lot. Like, there have been studies, some of you have even know about these studies, that have been studies in elementary schools, that the homework that's assigned in elementary schools often doesn't actually improve performance. Like those poor elementary kids that are in 4th grade that are coming home with like 2 hours of homework a night, they've actually proven in studies that that does not increase your performance. Now, a lot of elementary schools aren't as advanced as ours. Our 4th graders are doing stuff that a lot of districts' 10th graders are doing. Really, seriously. If you look at our 4th grade NWEA scores, they are close to some districts' 10th grade NWEA scores. So in other words, our kids in the elementary school are kind of like doing high school stuff. And you guys, a lot of you guys are taking college courses. Really. There's a lot of kids that graduate from Minnetonka High School with their first year and a half of college done. My daughter took 9 AP and IB classes. She tests right now. She's at I think she's still sophomore, but next semester she's going to be testing as a junior, even though she's a freshman. She's at a junior level. So she gets to register for her courses way earlier than everybody else because she's got so many credits. It's like she's been in college for 3 years and she's only been there for 1 semester. Or 2 years. Anyway, the point is, my theory on homework is that in high school, it has been proven that doing some homework helps. But I think sometimes people go overboard on how much they give. Because I know doing some versus none helps you remember it better because you touch it one more time. It's like repeating something. You know, if you have to remember something, repeating it is a way to do it. If you repeat it, you repeat yourself like 5 times and then you like wait 3 days, you'll have forgotten. But if you repeat it like 4 times and then repeat it once the next day, it really helps it stick longer. So it's touching this topic we just talked about. If you touch it again tonight, even if it's only a few problems, it's going to help you remember it way better than if you just like totally forget about it for 24 hours. But I don't need you to do like a ton of practice problems. That becomes less and less benefit. It's called diminishing returns. So I'm going to have homework for you pretty much every night, but it's not going to be like tons of problems because I don't think you need tons to get this. But there's always the exception to the rule. And the kid that says, I actually could use some extra practice problems, you just go do the ones we skipped. Or just don't listen to the directions and you can do them all. All right. That's all I got for you for today.